Hello, 8th grade. This is your Unit 3 review. Starting at the top, we have some math vocabulary and some academic vocabulary. What I've gone ahead and done is I have defined each of these terms. So first we have linear equation, an algebraic equation where each term is either a constant or a product of a constant and a single variable. So something like y is equal to 2x plus 3. Rate of change measures how one quantity changes in relation to another. So that would be your slope. So then the definition of slope is that measures the steepness, incline, or grade of a line defined as the vertical change, which is the rise, over the horizontal change, which is the run, between any 2 points. And if you have a slope, it's going to be a constant increase or decrease. Slope-intercept form is a common linear equation format written as y equals mx plus b, where m is the slope and b is the y-intercept. So it literally tells you what it is in the equation, slope-intercept. System of linear equations, a collection of 2 or more linear equations involving the same set of variables. So we might have 3x plus 4y is equal to 8 and 5x plus 7y is equal to 12, something like that. The y-intercept, the point where a graph crosses the vertical axis, representing the function's value when x is equal to 0. Eliminate or elimination, to remove a variable from a set of equations or a term from an expression. So if we had something, let's do a new one. 2x plus 4y is equal to 7, and 4x plus 7y is equal to 12. We can get rid of these x's very easily. Infinitely many, when any value plugged in for the variable makes the equation true. This means that the two sides or the two equations are identical, representing the same line. So if you remember, there's 3 ways that an answer could, 3 ways graphs can intersect. We had 1, none, or infinitely many. So this is an example of those 2 lines meeting. And lastly, substitution, the process of replacing a variable with a specific number or an algebraic expression to evaluate, simplify, or solve equations and formulas. So now that we have those definitions, we can go ahead and answer these questions. So the first question says, which math academic vocabulary terms could you use to describe ways to solve systems of linear equations? So if we're looking through these, there's 3 ways. So there's graphing, which isn't on here, or substitution, and elimination or eliminate. Number 2 says use at least 3 math vocabulary terms to label the parts of the equation. So here we have our slope. This is our y-intercept. This whole thing is slope-intercept form. You could also do rate of change. This is also a linear equation. Any of those would work. Number 3, use 2 math vocabulary terms and 2 academic vocabulary terms. So you're doing 2 of these and 2 of these. Excuse me. To describe the system of equations. Underline each term that you use. All right, so an example would be both of the equations are linear equations. top equation is in slope-intercept form. When you solve the second equation, the system has infinitely many solutions. One, two, three. One more. And then lastly, you can solve this system with substitution by replacing y with 1/2 x plus 4 into the second equation. All right, number 4, choose a math or academic vocabulary term from the box that you have not used as an answer. If you have used all the terms, choose one you only used once. Okay, so we've used linear equation, we've used rate of change, we've used slope, slope-intercept form, system of linear equations. Did I use that one? No. Y-intercept, eliminate, infinitely many, and substitution. So really you're just writing down one that you did not use. All right, next page. Trevor mixes bananas and strawberries to make a smoothie. He makes this graph of the amounts of bananas and strawberries to mix. Which statement is true about the line? A says the line does not have a proportional relationship. This is increasing at a constant rate, so that is not correct. The unit rate for the proportional relationship in the graph is 5. So if I come here to about 1, that is not 5, so that is not correct. The slope tells how many scoops of banana for each scoop of strawberry, so that is correct. The rise over run is greater than 1, and again, if we come here, that is not correct, so it is C. All right, question 2. How many solutions does 3/4 times the quantity 8x minus 4 equal to 3 minus 6x have? So basically all you have to do is solve for x. So I'm going to rewrite this. This 3/4 needs to get distributed inside the parentheses. So 3/4 times 8 over 1 x minus 3/4 times 4 over 1 is equal to 3 minus 6x. 3 times 8 is 24, divided by 4x. That becomes 12 over 4 is equal to 3 minus 6x. 24 divided by 4 is 6. 12 divided by 4 is 3. Okay, then I need to continue solving. So I'm going to add 3 to both sides. So this ends up being 6x is equal to 6 minus 6x. I'm going to add 6x to both sides. So I have 12x is equal to 6. I'm going to divide both sides by 6. 2x is equal to 2. So because I'm able to get an answer, there's only one solution. So then I would substitute that in and figure out my y, and that would give me both points. All right, question 3. Sierra and Bethany save money using savings accounts opened on the same day. Both deposit $20 to start and an additional $15 each week. The graph represents the total amount Y in each savings account after X weeks. Describe the number of solutions modeled in the graph and what it means for the situation. How can you change the situation so that the graphs model a different number of solutions? Explain your reasoning. Okay, so some key information is they opened it on the same day. They both deposited $20 to start, and they both are adding $15 each week. So basically, their graphs are going to be the same. So no matter at what point, they're going to have the same amount of money. So since the lines are the same, the number of solutions is infinitely many. So again, at any time, they will have the same amount of money. Now to change it, there's 3 things that can be changed. They open on different weeks. They start with a different amount. Or they add different amounts each week. Maybe Bethany adds $10 and Sierra continues to add $15. So those are the different ways that you could make it so that the graph is not the same. All right, last one. Jackie runs and rides her bike. She runs 6 miles in an hour. She bikes 18 miles in an hour. Last week she ran and biked a total of 216 miles. It took her 16 hours. How many hours did Jackie run and bike last week? Show your work. So basically what you have to do is you have to create 2 different equations. So the information that we have is she runs 6 miles in 1 hour and she bikes 18 miles in 1 hour. Last week she did a total of 216 miles and it took her 16 hours. So the 6 miles that she runs, 6R, plus the 18 that she bikes is equal to 216. So we know that she did a combination of both, of running and biking, and she can run 6 miles in 1 hour and 18 miles on a bike, and she did 218 total. We also know that the running plus the biking was 16 total hours. So these are my 2 equations. So now all I have to do is I have to solve for one of these. This one is going to be easier to solve because you have less stuff there. And then solve for the rest of them. So I have R plus B is equal to 16. I'm going to solve for R, so I'm going to subtract B from both sides. R is equal to negative B plus 16. Now, this one always goes into the opposite equation, otherwise you're going to get the wrong answer. So this right here goes into this top equation. Anytime I see an R, you're going to replace it with this negative B plus 16. So I have 6 times a negative B plus 16 plus 18B is equal to 216. So I'm just going to multiply these out. So this becomes a negative 6B plus, just come over here for a second, 96 plus 18B is equal to 216. Now I can simplify, so this term and this term are the same. I can simplify those, so that becomes 12B plus 96 is equal to 216. I'm going to subtract 96 from both sides. So I have 12B is equal to 120. Divide both sides by 12. B is equal to 10. So according to this, she would bike 10 hours. So now I have to take this 10 and I can replace it back into either one of my original equations. You're not going to do the changed one. You're always going to do the original. Since this has less numbers and less information in it, this one's going to be easier. So I have R plus B is equal to 16. I know that B is equal to 10. So I'm going to replace that in. I'm going to substitute it. Subtract 10. R is equal to 6. So she biked 10 hours and she ran 6 hours. Now a good thing would be to replace it back into the second equation, the one that you didn't use, both values to see if it works. So I would do 6 times 6 plus 18 times 10 is equal to 216. Trying to figure out if that's true. So we have 36 plus 180. Is that equal to 216? Yes, it is. Okay, so it checks. If you have any questions, please reach out and remember to bring these with you, and good luck tomorrow.